Hello there. I would love to introduce you to a multiplication strategy called the Japanese multiplication strategy. It is called the Japanese multiplication strategy because it originates from Japan. It involves substituting numbers for straight lines. And in this video tutorial, we will focus on multiplying two-digit numbers together. Let's begin with our first example. Calculate 13 times 21. Calculate, example 1, 13 times 21. So, for us to be able to calculate these two numbers which we have been given, we have 13 there and we have 21 there. What we are going to do is that we are going to substitute these numbers which we are seeing with straight lines. How do we do that? Follow me closely. So, firstly, we are going to draw a straight line like this. A straight diagonal line in that way. So, this straight line represents that one. This one line represents that one which is over there. So, we are going to draw three more straight lines, diagonal lines apart in that way. So do 1, 2, 3. So this line represents that one, 1, 2, 3 represents that 3 in that way. Having done that, now we have the multiplication sign and then we have 2 and 1 there. So we're going to represent that 2 with 2 more lines crossing in that way. So do 1, draw 2 lines, 2. So these 2 lines represents that 2 and we'll leave a gap midway there and we'll do 1 more line there in that way. So this line represents that 1. Having drawn this pattern in this way, we are going to separate or maybe segment these lines we've drawn into 3. So we have that one there, that one there, and that one there. So what we are doing is that these segments, we are making segments where the lines we are crossing. So this represents the ones, this region represents the tens, that region represents the hundreds. Okay, let's begin from the right to calculate. So what we are doing is that we are calculating where the lines were crossing. So where this line crossed or the intersection, so we count those ones, 1, 2, 3. So we indicate our 3 on top there. We go to the next one. Where did the lines cross? Got 1, 2, 3, 4, 5, 6. Then we also add this one, 7. Since it's one region, so you count where the lines crossed in this whole entire region. So there we have 7. Then we go to the 100 section, 1, 2. And we show our 2 in that way. So 13 times 21, it gives us 273. So we say the answer for 13 times 12 is 273. Alright, now we go to the second example, which says calculate 32 times 12. Calculate 32 times 12. So we have 32 there times 12. So the same way we did with our first example, we start by drawing lines. So we are going to represent that 3 with these lines here. 1, 2, 3. So 1, 2, 3, they represent that 3. So we're going to leave a gap midway there, and we're going to do 2 lines to represent the 2. 1, 2. So these 2 lines represent that 2 times. All right, so now we're going to do that. 1. This line represents that 1, and we'll leave a space midway there, and we'll draw 2 more lines. 1, 2. These 2 lines represent that 1 there. Okay, so just like we did with the first one, we're able to separate the pattern which we've drawn into 3 segments, which are going to represent the place values. So this first one, where the lines we are crossing, represents the ones, the place values for the ones, and then the middle region there represents the place value for the tens, and the final region, the last one here, represents the place value for the hundreds, in that way. So like we did in our first example, we are going to add all the crosses which we have, and we'll write the number on top. So we'll count the intersection here: 1, 2, 3, 4. So we'll show 4 there. We go to the middle region. We have 1, 2, 3, 4, 5, 6, 7, 8. So you have 8 there. Then we go to the hundreds section. We have 1, 2, 3. So you have a 3 there. So 3, 8, 4 is what we get as our answer, which means 32 times 12 is equal to 384 as our answer in that way. I hope you are following us. Let's go to our third example. The third example says 14 times 23. 14 times 23. Now you notice that as we go on and on, it becomes a little bit more complicated. So I would advise that you stay glued and be able to follow through so that you don't miss any step as we solve these multiplication questions using the Japanese strategy. Okay, as usual, we begin 1 to represent that 1, leave a gap, do 4 lines, 1, 2, 3, 4. Okay, so that one, it's that 1, 1, 2, 3, 4, that's the 4. Multiply by 1, 2. So this 2 represents that 2. 1, 2, 3. This 3 represents that 3 there. So we'll do the same like we did in the previous questions. That's the this is the ones section. The tens section, and you have the hundreds section. So remember, these are just more like placeholders. So let's count the crosses, the line crosses, or rather the intersections. We'll start from our right there. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So you have 12, so you can write it there. So you have 12. So most of the time, you know this is the one section. So the one section cannot have the 12 in that way. So since the answer that we got is 12, you are going to remain with the last digit in that way, and we're going to carry the 1 and we'll give it to the middle section. So you can indicate a 1 there, plus the plus will show whatever we're going to add from there. So we're going to add that 1 which we've carried from the 1 section to whatever we're going to find on the middle part there. So let's begin to count the middle part. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11. So 1 plus 11 is equal to 12. 1 plus 11 is equal to 12. So since this is equal to 12, what we do is that the middle part, we won't write the 12, but instead we'll only write the last number, which is a 2 there. So we'll only have a 2 there, and we'll carry the 1 to the hundreds section. So we carry the 1 so that we add it to whatever we're going to find on the hundreds. So there we have 1, 2, which is equal to 3. So what we are seeing is that on the 100 section we have a 3, on the 10 section we have a 2, and on the 1 section we have another 2. So we're looking at 3, 2, 2. So 14 times 23 is equal to 322, and that is our answer right there. That is the answer that we get. We go to our fourth example. The fourth example says multiply 25 times 31. Multiply 25 times 31. So we begin with our diagonal lines. 1, 2. Then we're going to draw 5 lines. 1, 2, 3, 4, 5. So 2 for that 2, 1, 2, 3, 4, 5 for that 5. All right, so now we draw 3 lines on the other side. 1, 2, 3. So these 3 lines represent that 3, and then we'll draw the last line being 1. Let's separate the sections. So you have this section, that section, and that section. So like we said, these are the ones, these are the tens, and these are the hundreds. So what do we have in the ones section, or in the region representing the ones? So we have 1, 2, 3, 4, 5. So we have 5 there. We indicate our 5 on top. Let's go to 10 section. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So since we have 14 here, we have 14. So we have 14 under this section. What do? We remain with a 4. We remain with a 4, and we carry the 1 to the 100 section. So we have our 1 there plus whatever we're going to find when we add. So we come to the 100 section. We have 1, 2, 3, 4, 5, 6. So you have 6. So you have 1 plus 6. This gives us 7. So what we are looking at is under the 100 section we have 7, under the 10 section we have a 4, under the 1 section we have a 5. So 25 times 31 is equal to 50. That's the answer that we get when we multiply 25 times 31. We are good now, we are doing fine. Let's finish with the remaining example, which says 37 times 19. 37 times 19. So 37 times 19 is the question we are solving. As usual, we do what we've been doing with the other questions. We're going to draw lines, 3 of them, to represent that 3. 1, 2, 3. And we are going to draw 7 lines here. 1, 2, 3, 4, 5, 6, 7. So 3 lines to represent that 3. 1, 2, 3, 4, 5, 6, 7 lines to represent that 7. And now we're going to show that 1 in that way. 1. Okay, and then now we're going to represent that 9. We're going to show that 9. So we'll draw 9 lines. 1, 2, 3, 4, 5, 6, 7, 8, and the final line being 9. All right. Well, we have a lot of work to do on this one. So let's divide our sections. We have the 1 section being there. The 1 section. You've got the 100 section being there. And we've got the 1 section, the 10 section, and the 100 section being in that way. So we have our 1s, our 10s, our 100s. Let's add together and see what we get. Let's add now. Let's start with the 100s there. The 1s rather. Let's start with the 1s there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63. So under the 1 section, we have 63. As you are counting these intersections or the crossings of the lines, just make sure that you do not miss out any crossing or any intersection, because if you do, you end up getting a wrong answer. So we've done it for the 1s. We now go and we do the same under the 10s section. So let's count the intersections. You have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34. So under this section, you have 34. What do you have on the 100s? You have 1, 2, 3. You have 3. You have 3 under the 100s section. You have a 3 under the 100 section. Now, like we did in the other previous questions, you know the 1s cannot contain 63. The 10s also cannot contain 34. So what do we do? Since this is a 63 under the 1 section, what you do is you are going to remain with the last number, the last digit rather. So under the ones, you remain with a 3, and then you carry the 6 to the tens section. So when you carry the 6, what we have is 34 plus the 6 which you have brought. So when we add the 6 there, what becomes of the tens section is, it is a 40. So what do you do when you remain with a 40? When you have a 40, you remain with the last digit there, which is a 0. So we're going to remain with a 0, and we're going to carry the 4 to the 100 section. We'll carry the 4 to the 100 section, so it will be 3 plus 4. So when we add 3 plus 4 there, it gives us a 7 in that way. It gives us a 7. So we are looking at the 100 section having a 7, the 10 section having a 0, and the 1 section having a 3. So 37 times 19 is equal to 703. 703 is the answer. 37 times 19, the answer is 703. Having done that, we would have answered all the 5 questions which we were given under the Japanese strategy. And so thank you so much for watching and for following us through. If you like this video, please take a look at my YouTube channel for more other educational tutorials. Please don't forget to like and subscribe.